What if the secret to building a truly advanced AI isn't about inventing something totally new? What if instead we just copied a design process that's been working for, a few billion years? Today, we're going to dive into how Mother Nature's own Playbook, its ultimate problem-solving tool, can help us crack one of the toughest nuts in artificial intelligence.
Okay, so let's get right into it. Building a powerful AI, what we call an artificial neural network, is just incredibly complex. I mean, there's no instruction manual. For decades, it's been this really painstaking process of trial and error. You've got brilliant engineers relying on gut feelings and experience to guess, how many layers should it have or what connections do we need. It's kind of like trying to build a skyscraper without an architect's blueprint.
But it turns out, nature has been solving these mind-bogglingly complex design problems for eons. And it uses one simple but incredibly powerful principle to do it: evolution. It's the ultimate designer, right? So researchers had this brilliant idea. Why don't we just borrow its playbook to build better AI? So how do we actually do this? Well, it all comes down to combining two key pieces of technology. The best way to think about it is like a partnership between the brain we want to build and the designer who's going to build it. So on one side, you have the artificial neural network, the ANN. This is our brain. It's this web of simple little processing nodes that, if you connect them just right, can learn and do amazing things. And on the other side, we have the evolutionary algorithm, or EA. This is our designer. It's basically a computer program that mimics natural selection to hunt for the absolute best solution to a problem. So, what in the world is an evolutionary algorithm? Well, instead of thinking of a detective following one single clue, think of it more like a giant search party spreading out over a huge area. Instead of testing one solution at a time, it creates a whole population of them. And then these potential solutions compete with each other. They share information, and they gradually get better and better over generations. It makes them amazing for tackling these huge, complex problems where other methods would just get totally lost. And this loop right here is the whole process in a nutshell. It's so simple, but it's incredibly powerful. First, you generate a whole bunch of random solutions. Then, you evaluate each one to see how fit it is, how well it solves the problem. Based on that score, you select the best ones to be the parents. They then create the next generation, and you just repeat that cycle, over and over and over, until an amazing solution finally emerges. And this is the big aha moment. What happens when we smash these two ideas together? What if we unleash our automatic designer, the evolutionary algorithm, on the problem of building the brain, the artificial neural network? Well, this brings us to a whole new kind of AI, evolutionary artificial neural networks, or EANs. And the key thing to get here is that evolution isn't just some add-on feature. No, it's fundamental to how they adapt. It allows them to change their own structure, even their own learning rules, all without a human having to step in. And that is absolutely crucial for creating AI that can handle the messy, unpredictable real world. Okay, so we can use this evolutionary idea at 3 different levels, each one getting a little more ambitious. Let's start with level 1, the most direct approach, using evolution as a personal trainer for our AI to fine-tune every single one of its connections. Now, the typical way we train a neural network uses an algorithm called backpropagation. It's pretty smart. It basically looks at its mistakes and takes the most obvious downhill path to fix them. It works, but it has one major flaw. It's a little short-sighted. It can easily get trapped in what looks like a pretty good solution, totally missing that a much, much better one is just over the next hill. This visualizes the problem perfectly. Imagine this wavy line represents how many errors the AI is making. You want to find the lowest possible point. A traditional algorithm might start up at the top, slide down to point A, and just stop. It thinks it's at the bottom because everything right next to it is higher up. But an evolutionary algorithm, with its whole population searching everywhere, can explore the entire landscape and find the true best solution all the way over at point B. So the benefits here are just huge. First, as we saw, evolution avoids those local traps. Second, it's way more robust. It doesn't need a perfectly smooth, predictable problem to solve, which is a lifesaver in messy fields like robotics or finance. And finally, it can be a fantastic team player. You can use evolution to find a really good starting point, and then let a faster traditional algorithm take over for the final sprint. But hey, just fine-tuning connections? That's only the beginning. Level 2 is where it gets really mind-bending. Instead of just training a network a human already designed, what if we let evolution be the architect? What if we let it design the network's entire blueprint from scratch? And this is so important,
Because the architecture, how the nodes and connections are all laid out, it's everything. If the design is too simple, it just won't be powerful enough to solve the problem. But if it's too complex, it can basically memorize the training data and then fail completely when it sees something new in the real world. It's that classic Goldilocks problem. It has to be just right.
Okay, so here we see a network's blueprint. The big question is, how do you translate this diagram into a language that an evolutionary algorithm can actually understand? How do you turn this picture into a genetic code that it can, read and change? The answer is actually pretty elegant. You use something called a connectivity matrix. It's really just a simple grid of ones and zeros. A 1 means, yep, there's a connection here, and a 0 means, nope, no connection. That's it. This simple grid becomes the network's DNA, a complete blueprint that evolution can read, mutate, and combine with others. So the evolutionary cycle works just like before, but it's operating on a whole other level. The algorithm takes that genetic matrix and decodes it into an actual network architecture. Then it trains and tests that network to see how it does. It gives it a fitness score, and what's really cool is that it can reward not just accuracy, but also simplicity, actively looking for smaller, more efficient networks. Then the fittest architectures get to breed and create the next generation of blueprints. This brings us to level 3, the final and, honestly, the most profound step. What if evolution could go beyond designing the hardware and start inventing the software? What if it could create the actual rules of learning itself? Yeah, this is a wild concept known as learning to learn. So instead of us giving an AI a fixed learning algorithm that a human came up with, we let the AI evolve its own. It could discover a totally unique learning process, one that's perfectly tailored to its own weird structure and the specific problem it's trying to solve. And this shows you how it works. You have a population, but not of networks. You have a population of learning rules. To see how fit a rule is, you use it to train a whole bunch of different networks on all sorts of tasks. The rules that consistently produce the best trained networks are the winners. They're the most fit, and they get to pass their traits on to the next generation of learning rules. And get this isn't just some crazy theory. In actual experiments, researchers started with a population of completely random, nonsensical learning rules. And just through this evolutionary process, the system all by itself discovered and refined rules that were basically identical to famous human-designed algorithms like the Delta rule. Just think about that. Without any help, it rediscovered a cornerstone of AI research from scratch. That proves evolution can be an engine for real invention. So, we've seen evolution as a trainer, an architect, and even an inventor. So what's the big takeaway? Why does any of this matter? It really all boils down to this insight from researcher Sin Yo, whose work was the inspiration for this whole explainer. The combination is just way more powerful than the individual parts. When you combine the learning power of neural networks with the incredible design power of evolution, you can create intelligent systems that are just leagues beyond what either technology could ever do on its own. And this really leads us to a final, pretty profound question. We're slowly moving away from designing AI ourselves and toward designing systems that can design themselves. So as we hand over the architect's blueprints and the inventor's notebook to evolution, what entirely new, maybe even completely alien forms of intelligence might just bubble up, all without any human guidance at all? It's a pretty wild thing to think about.